So complex numbers become a lot easier to understand if you can understand powers of I. And what I mean by powers of I is I to the first power, I to the second power, I to the third, fourth, fifth, sixth, 75th power, I to the negative 10 power, all different powers of I, okay? Now I is what we call a modulo or a mod. It's mod 4. What that means is that there are really only 4 answers to any power of I. Let me show you what I mean. We know that I is equal to the square root of negative 1. And so if somebody said, well, what is I equal to? Well, you would just say that it's equal to I. There's no other way of saying it. If somebody said, what is I to the first power? I to the first power is equal to I to the first power. It's just equal to I. But I to the second power is a little different. See, I to the second power is equal to I times I. And since I is the square root of negative 1, we would do the square root of negative 1 times the square root of negative 1. Whenever you multiply a square root of something by itself, all it does is cancel the square root. So the square root of negative 1 times the square root of negative 1 is equal to negative 1. And therefore, I squared is just equal to negative 1. This is important because in a lot of problems involving complex numbers, we often encounter I squared. And we can take the I squared out and put in negative 1, and it makes it very easy to solve the problem. Okay? But what if we were to move on to I to the third power? Well, I to the third power is I times I times I. And we know that I times I is I squared. So this is the same thing as I squared times I. And we know that I squared is negative 1. So this is negative 1 times I. Remember I said you can take I squared out and put in negative 1. So we've got negative 1 times I, which is just simply negative I. So if somebody said, hey, what's I to the third power? You could just say, well, that's negative I. And then there's I to the fourth power. And that's pretty much where we stop, I to the fourth power. Well, I to the fourth power is the same thing as I times I times I times I. That's 4 i's being multiplied. We know that I times I is I squared, and I times I is I squared. So we have I squared times I squared. It's the same thing as I to the fourth. Well, I squared is negative 1. And this I squared is also negative 1. And what is negative 1 times negative 1? Well, that's 1. And so all of our answers wind up revolving between, they go I, negative 1, negative I, and then 1. And what's the next one going to be? Well, I to the fifth, well, it's going to go back to the beginning. I to the fifth is going to be I. Then I to the sixth is negative 1, I to the seventh is negative I, and I to the eighth is 1. Let me prove it to you. I to the fifth is the same thing as I to the fourth times I. Look, that's 4 i's, a fifth I to the fifth. Well, I to the fourth is equal to 1. And then times I. Well, what's 1 times I? Well, that's I. Anything times 1 is itself. And so, this is I to the fifth. This is going to be I to the sixth. I could do the exact same thing. I to the sixth is equal to I to the fourth times I to the second. That's 1. I to the second is negative 1, so this becomes negative 1. I to the sixth, I to the seventh, I to the eighth. I to the ninth, I to the 10th, 11th, 12th. So the question is, what do we do when we get something like I to the, 140, third power? What do we do with that? All right, so these are 3 crazy situations that you might face. I to the 143rd power, I to the negative 18 power, and then something like I to the 12th over I to the 21st. So basically what you're going to do is you're just simply going to keep subtracting 4 from this. If I subtract 4 from this, I get 139. If I subtract 4 again, I get 135, then 131, then 127. But I don't have to do it one at a time. All I have to do is subtract a number, 143, a number that is divisible by 4. Well, I know 100 is divisible by 4. 100 divided by 4 is 25. So I can just subtract 100. So this is the same thing as I to the 43. I also know that 40 is divisible by 4. 40 divided by 4 is 10. So I can subtract 40. And it winds up being I to the third. And we know that I to the third is negative I. And therefore, I to the 143rd is negative I. We're done. We can do the same thing with adding 4s. I to the negative 18, if I add 4, becomes I to the negative 14. Add 4 more and I get I to the negative 10. I can also add any multiple of 4, like 12 is a multiple of 4. 12 divided by 4 is 3. So if I add 12 to this, I get I to the second power, which is negative 1, and I'm done. So I to the negative 18 is the same thing as I to the second power, which is negative 1. And then lastly, whenever we deal with this, when we have I to the 12th power and I to the 21st power, we have numerator and denominator. This is the same thing as I to the power of 12 minus 21. So this power subtracts this power, 12 minus 21. And 12 minus 21 is negative 9. So this is the same thing as I to the negative 9. Then we can add 12 again. If I add 12 to negative 9, I get I to the third power, and I to the third power is negative I. So I to the 12th over I to the 21 is the same thing as I to the third, which is negative I. And so this just takes a lot of practice doing a bunch of these, and it should eventually become familiar. But understand that there are only 4 possible answers.